All right, in 5.3, we're going to kind of switch gears. We're still talking about money, but it's going to be different than what we were doing in 5.1 and 5.2. In 5.1 and 5.2, we were depositing or taking out a loan just one time. There was a one set P that we were dealing with. Now we're going to change gears and we're going to talk about ordinary annuities. And in ordinary annuities, a one-time payment or deposit is not made. Instead, we have payments, a sequence of payments that are made at the end of each end time period. So for instance, a lot of times like a retirement account, you'll deposit so much money in each month. So that deposit is continually coming along. It's not just a deposit of $10,000 at the beginning. Instead, it's a deposit of $100 each month. And those are the types of problems that we're going to be dealing with these ordinary annuities. So the value of the annuity increases from 0 at the beginning. So we start with nothing in our account, and then we keep putting money into it. And we get larger and larger. Our annuity grows into larger and larger things. The future value is the total amount of the deposits made and the interest earned. So if I want to know the future value of my retirement, then I would include continuing to make deposits every month for 15 years. So it's not the value like right now. We're going to get to that in the next section, but it's the value if we kept making those payments for the entire length of the account. And the frequency of the time period is the same as we were looking at with the compounding interest. So if we come back up to our formula, this is also on page on our page 47 here that we've been dealing with. We've got it right here. We've got most of the same letters. Like I was saying, the frequency is the same. So N is the same. Our T for time is the same. And our interest rate is the same. We do have two new letters here. S is going to stand for that future value out of everything, like if we were to keep making those deposits. And the capital R is going to stand for how much we are depositing at the end of each month or each quarter or whatever our period is. And then just remember that we're going to round to 2 decimal places because we're dealing with money. So let's get started with this formula. In this first one, I'm going to deposit $1,200 semi-annually. So I know that I am using this formula because I'm depositing more than once. It's going to talk about that semi-annually again, and we saw that with the compound interest in 5.2. So the difference is 5.2 was a one-time deposit and 5.3 is we're depositing over and over again. So we're depositing semi-annually, that's twice. We're doing that for 5 years, and our interest rate, be careful, is 0.0065. So I'm going to plug this into my formula, and it is a challenge to type in. So I would tell you to take your time and not try to do all of it at once. So you're going to see I'm going to type in parts of mine. So I don't try to type all of it at one time. I do it in parts. All right, I'm actually going to come over here to give myself a little bit more room because I wrote kind of large. I'm going to come over here and write it out. So what I do is I'm going to keep that 1,200, and then I'm going to type in this top part. And you can type it in exactly how it is with those parentheses to get a nasty decimal. And just like we saw before, you want to keep your entire nasty decimal. Yours might be off a little bit at the end. That's okay. As long as we're 4 or 5 decimal places out, we'll be good. Then I'm going to type in the denominator. I'm going to keep all of that decimal place. Now, I can type all of this in my calculator. You can use brackets, or you can just treat this as a giant set of parentheses, because brackets and parentheses, in this case, have the same function. They're just a grouping symbol. And I'm going to type this in, and now I can round my answer to 2 decimal places. So again, I would split up, type in the calculator, because if you do it all at once, it's possible, but it takes lots and lots of parentheses. All right, let's look at this second example. This one, we saw this kind of format in 5-2. We're going to do a little bit of algebra. So instead of telling you how much you're depositing, I tell you how much you need. Larry needs this much. So this is that time travel again. So I'm going to set my equation equal to 10,000. I didn't tell you what you're depositing. We're going to have to solve for that. I did tell you that we're doing it quarterly, and the interest rate, and the time. So I would have $10,000 is equal to R times this set of brackets. I'm plugging in all that data. Again, I would type in just the numerator. Then just the denominator. And if you need to hit pause to check those, you can. I've got mine already kind of pre-typed in, so you don't have to wait on me to type them. But if you need to hit pause to check and make sure you're getting those, you really need to make sure that you know how to type these in the calculator. All right, now I'm going to type in my calculator all of that. And if you want to use parentheses, you can. We can't type in the R. So I'm going to get another really long decimal. I'm trying to get R by itself, so I'm going to divide by 39,000. Or sorry, 39. Whew, that's a decimal place. I'm going to divide by that 39, the whole thing. I'm not rounding. And that's going to tell me this answer I can round, that if I want to have that $10,000, I need to deposit $256.08 every quarter. I keep putting that money in the account. After 8 years, the balance of the account will be $10,000.